This project is focused on the chemical analysis of blue and green semi-precious stones excavated from the Wari site of Cerro Baúl. The purpose of this analysis is to identify and compare the stones as well as contribute to their geographic sourcing. Prestige goods such as personal ornaments made from metal, shell, semi-precious stone, or a compilation of these materials are often valuable indicators of cultural affiliation, status, and the political economy. Tracking the sources of component parts of such goods can shed light on the organization of production, control of resources, or networks of exchange. The Wari Empire existed from approximately 600 to 1000 CE in the central Andes of South America. Cerro Baúl is a towering mesa located in the Moquegua River Basin. The basin was colonized by both Wari and their southern neighbor Tiwanaku, which formed a border region between the two polities. The Wari constructed a settlement atop Cerro Baúl, which included socially stratified residences including a palace, workshops for lapidary production, temples, and a monumental brewery. The site likely functioned as a diplomatic and ceremonial center for interactions between Wari and Tiwanaku representatives. The Moquegua Basin was the only area in which the two states directly bordered each other, making an impressive diplomatic outpost especially useful to represent the power and influence of the Wari Empire. At Cerro Baúl, Wari elites had connections to widely spread networks of resources, possibly through their interactions with their Tiwanaku neighbors to the south. Excavations at the site have revealed several semi-precious stones and areas where these materials were shaped into ornaments such as beads, pendants, and tesserae for mosaics. For this study, I used a portable X-ray fluorescence, or pXRF machine to analyze semi-precious stones excavated from Cerro Baúl in 2001, 2002, 2004, 2007. These stones were classified as either blue or green. The blue stones were believed to be primarily Sodalite, while the green stones were believed to be primarily Chrysacolla. 118 green stones and 111 blue stones were analyzed. In addition to the excavated stones, I analyzed multiple other stones from other archaeological contexts, as well as some in modern jewelry. The blue and green stones excavated from Cerro Baúl were housed in the collections of the Museo Contisuyo in Moquegua, Peru. Each stone was analyzed for 480 seconds by the pXRF machine. In order to monitor the data for errors, two chemical standards were scanned at the beginning and end of each day, as well as after every 5 stones were scanned. Every 5th stone scanned was also scanned 4 additional times to ensure that the pXRF was producing consistent results. The other stones included for comparison were each scanned 5 times. Similarly to the stones from Cerro Baúl, 2 chemical standards were analyzed at the beginning and end of each day of scanning. Once all the data had been collected by the pXRF, the data was analyzed in JMP. For the purposes of this project, multivariate principal component analysis was used to find correlations in the data. Each analyzed stone from Cerro Baúl was also identified by color according to the Munsell color system. This was achieved by comparing each stone to a standardized Munsell color chart. Analysis in JMP revealed multiple interesting relationships among the chemical compositions of the samples, some of which mirrored physically observable traits in the stones themselves. Among the blue stone, there was a smaller range of colors than in the green stone, which varied significantly. This was reflected in the tighter clusters of blue stone and the more sparsely distributed green stone. Although the blue stone and green stone did not overlap very much in their primary chemical compositions, principal component analysis indicated a 40.3% correlation in one component of the data. This correlation may suggest that there are similarities in the underlying trace elements of these samples, which are often indicative of the environment in which they were initially formed. Although preliminary, these results are promising and encourage further chemical analysis for the purposes of identification and geographic sourcing. Although pXRF is a valuable tool, other more intensive chemical analyses, such as instrumental neutron activation analysis, may yield more concrete, applicable data in the future.